A model for predicting flood inundation in coastal cities. Why should planners care about flood inundation models? It is necessary to know which areas will be flooded during a wet weather event for planning new development, creating strategies for the mitigation of coastal climate risk and sea level rise, drinking water quality management, and other risk mitigation practices. The flood inundation risk model can also be used as a quantitative tool to create policy concerning planning and development, water resource management, and municipal disaster response protocol. What makes this model different? This model was created using reliable flood inundation data taken from a real-time extreme wet weather event in Calgary. This allows our model to not only be theoretical, but grounded in real-world data. What is the goal of this model? Our team's goal in creating this model was to predict flood inundation in a way that can be replicated for any coastal city. What is our team's modeling strategy? Our modeling strategy is to use ArcGIS to generate features, which can be used as factors in flood predicting modeling, then to use R to create a model using those features. Features. Which features did we choose? Why did we choose them? How did we create them? How did we create features? All the features were created using ArcGIS, a mapping program.
What features did we create? First, slope. The flatter an area is, the more likely it is to be flooded during a wet weather event. Next, distance to steep slopes. The steeper a slope is, the faster rain will move toward the lower end of the slope. This leaves areas near high slope points vulnerable to flash flooding. Vulnerability to flash flooding is an integral part of flood inundation modeling. Normalized difference vegetation index, or NDVI. Trees take up more water than shrubs, which take up more water than grass, which takes up more water than bare earth. The NDVI allows us to differentiate between those categories to see which areas will be able to absorb more water during flooding events. Next, distance to hydrological features. The closer a location is to water, the more likely it is to flood during a wet weather event. Therefore, a location's distance to a water body is very important when modeling flood inundation. When modeling a flood, it's important to know where water will accumulate as rain falls on the surrounding landscape. The more water accumulates, the greater the risk of flooding. Next, land cover. The permeability of a given area, or its ability to absorb water, is essential in flood prediction modeling. Land cover illustrates which surfaces are impermeable or permeable. Results, including the relevance of each feature. This histogram represents which independent variables are most relevant for predicting inundation. Flow accumulation was the greatest predictor of areas which would flood, and Euclidean distance from slope was the greatest predictor of areas which would not flood. This curve maps the fraction of true and false positives. The area under the curve is a great indicator of the accuracy of the model. This matrix provides statistics for the model results. Sensitivity refers to the number of true positives, or areas which were correctly predicted to flood. Specificity refers to the number of false negatives, or areas which were correctly predicted to not flood. The accuracy rate for predicting areas which will flood was 44.48%. The accuracy rate for predicting areas which will not flood was 98.76%. These maps are the final output of the model. They are flood inundation maps of each city, which provide an accessible tool for both planners and policymakers. Although preliminary, these results show an acceptable margin of error for flood inundation prediction. A 98.76 accuracy rate for predicting areas which will not flood is an extremely useful tool for predicting areas which will be safe for future development. The next step in creating a more nuanced flood inundation model would be to gather real-time flood inundation data from future wet weather events and to fine-tune the model using that real-world data. Our team also plans to add more and different features to the model in the future to aid in increasing the accuracy of the model when used for different cities.